So this lesson is going to center on two things. The first thing is, okay, let's look at the objectives, thought-provoking tasks. What happens to the object that is thrown upwards in terms of one, its velocity. As the object starts going up, at the beginning of its motion, does it have the velocity? Will this object continue going up, or there will be a point when this object starts to go down? You throw an object going upward. Will it go up forever? If not, what are the comparisons between the velocity that the object will start with as well as the velocity that this object will have at the end of the journey? That's what we're saying, talk about it in terms of velocity. Secondly, what are the equations that we can use to talk about the factors or to talk about the parameters that are acting on this object? Now, first of all, when this is happening, we need to understand that there are certain factors that are present and there are others that are ignored for some reasons. Then secondly, we are saying that how many forces are acting on the object. So if we say this object was thrown upward, the only way this object will reach a certain point and then changes the direction, starts falling down, it is because there are a lot of forces that are acting on this object, and these are the forces that are causing an object to stop moving, and then thereafter it changes the direction. So these are the things that we have to understand. Now we are talking about an object that is thrown upward, which is by far different from the object that is falling freely. So if an object starts falling from a cliff, we'll talk about the initial speed it will have before it starts falling, and the final speed it will have when this object is caught. How is this velocity changing? Is there a constant way? And things like that. So these are things that we have to talk about in today's lesson, coming from linear motion. Now, if we go to the next question, okay, now this is the opposite actually that I talked about partly. We're saying explain what happens to the object that is undergoing a free fall. So free fall, it's different from a situation when an object is thrown downward. When you throw an object downward, you are applying force. As a result, the motion of that object also is as a result of the force you applied on it. Now, this free fall we're talking about is where you had a phone placed by the bench and then accidentally it starts falling. So there's no force applied on it as it starts falling by a human being. It's free. It's that fall where a human being has no action. So in terms of its velocity, in terms of does it change its velocity in a positive way or in a negative way? How many questions can we talk about? And what are the types of forces that are acting on the object? So these are the two that I want us to look at. Because you said that you had a little bit of issues.
Yes,
Can we move on now?
yes, okay.
Okay. So here's the thing. We're saying we're starting with the motion of a free fall. You have to note, because this is a presentation, so let's not say recall. We have to note that when an object is undergoing a free fall, it was positioned up here, and then maybe the wind pushed it towards the edge, and then it starts falling. So in the first place, this object was at rest. Now, when you say the object was at rest, we're talking about the object having the initial velocity of 0 meters per second. So some of the apparatus that are acting on this object is the initial velocity, which is 0. Reason being, when this object was positioned up here, it was not moving. So the initial velocity for a free fall, it's 0. Now, to distinguish the final velocity and the initial velocity, in most cases, the initial velocity that I presented as Vi is denoted by letter U. And what else do we need to have? So this is the point that is explained here, that remember that as the object undergoes free fall, its initial velocity is 0. So the initial velocity symbol is U, and the value is 0 meters per second because the object was at rest. Secondly, what happens because this object now is falling, and when this object is caught here, it will have a certain value of velocity, which is actually enabling it to fall, because the object is moving, meaning it has attained a certain velocity, which enhances its mobility. So we are going to have the final velocity, and that final velocity, we are representing it by V. And in practical terms, the final velocity for a free fall is always greater than the initial. Why? Because the initial is always 0. The object was not moving. For as long as this object is moving, we are going to have some value of velocity, which is in a positive way, and that's why we're saying its value is bigger than 0. Now, there is a relationship between how long it will take to reach the ground as well as the distance. So actually, the distance covered by the object is dependent on how long it takes. So if an object takes longer, let's say you've charged your vehicle, these electric vehicles, you've charged them, and then 2 of them actually are charged at the same time, then they are being driven at the same velocity. The one that will take longer to run out of power will cover a longer distance. I hope you're getting it.
Yes.
So saying there's a relationship between how far the object goes and the amount of time taken. So the distance in this way is denoted by letter S. Sometimes we put X. Now, what else would we say? Because at the beginning the velocity was 0, and at the final we have some value, therefore there is change in velocity. Now, change may be from smaller to bigger or bigger to smaller. But the one we're talking about here is from smaller to bigger. So we are saying that the object is accelerating. But the question is, how is this velocity actually changing? There is a numerical value. Actually, the truth of the matter is that each second the object takes to fall, the speed increases by 10 meters per second. So basically what it means is that if there's an object that is falling, as I was saying, how long it takes depends on the distance. So this object which is here, the velocity is 0 and the time is 0 before it hasn't started falling. Now, each time it covers a single second, the value increases by 10. Another one, we also add another 10, which will give us 20. Another one will give us 30, and so on and so forth. So when you drop an object, and then you calculate the number of seconds the object has taken to reach the ground, you are able to tell the final velocity that that object will have. How do you do? By just multiplying the time taken as well as the value, which is 10. Because each second covered, the value increases by 10. So if it takes 10 seconds, the object will have a velocity of 10 times 10, which is 100 meters a second. Now, if you look at what we have here, the change in velocity is constant. The change in velocity is constant. It's changing actually by 10. Every time you add 10, every time you add 10. So because the change is constant, therefore we are going to say that the rate of change, which is constant, gives us the constant acceleration, or which is the steady acceleration. Now, because the object that is falling is as a result of the force of gravity that's acting on it towards the Earth, that's why we call this change in velocity as acceleration due to gravity. So to find the height that the object covers as it falls, having known the amount of time taken, this is the formula that we use. S is equal to ut, initial velocity multiplied by time. We add to half of the acceleration due to gravity multiplied by time squared. Now the acceleration due to gravity is 10. This very change that we witnessed over here. Can we move on?
Yes, sir.
But one thing you have to understand is that the initial velocity is 0. And therefore, in our equation, this point where we have a 0 on u, even if you multiply by a very huge value of t, it still gives us 0. So as a result, there is a better simplification that we have, saying that these are the parameters that are represented in the equation, but we have to take note that here we have a 0, which even if you multiply with the numerical value 10 here, you are still going to get a 0. And even if we add 0 to whatever values we are having, it will not change the values. As a result, we are saying that this part disappears. We only remain with distance being equated to these two. So whenever we are talking about a free fall, we can calculate the distance that an object covers for as long as we know the amount of time that it takes. Because that's what I said, that there is a relationship between the time taken as well as the distance covered. And this is a relationship. So if we go to a certain question that is talking about that, we may have that. It's just bad that solutions are already there. I wish I'd hidden them in one or the other, but it's all right. So saying an object falls from the top of the cliff and only takes 4 seconds to reach the ground. Now we're going to ignore air resistance because we understand that when an object is motion, the air resistance always opposes to the direction. The example I'll give you is that when you're cycling a bicycle, you open up your shirt, you'll find that you're going to see how the shirt acts as if it wants to fly backward because it's being pulled backward by the air resistance. But this free fall that we're talking about here, we're saying that that opposition force coming from the air resistance is being ignored. So I'll send you this PowerPoint, and then when I upload on YouTube, I'm also going to add this on the description in my drive where you can download it. So we're told to calculate the height. How far was it for this object? So remember, we said that because the initial velocity is 0, so this part, if we so wish, we can just ignore it so that we say half. Now remember, physics, it's always important that we start the formula so that we show the markers that these findings are actually yours. So we're going to say half multiplied by the acceleration due to gravity is 4, multiplied by the time taken is 4, and the time is squared. So when you have 1/2 multiplied by 10, multiplied by 4 gives us 16. And here we can now divide 2 and 16. So 2 there gives us 1, 2 there gives us an 8, and this is actually the 8 that we're multiplying with 10, and the answer will be 10 meters. 80 rather, 80 meters. So this object was highly positioned, about 8 meters. That's why it took 4 seconds. Now, there is a very strong argument where somebody says, what happens if the object that is falling is a smaller mass and the other object falling has a larger mass? How does that affect? So like I said, that there are many things that act on the object, but some of them are ignored. Like we ignored air resistance. So even in this case, the mass is ignored. But practically, we understand that the object that has a larger mass, we expect it when it drops, it reaches the ground earlier than the lighter one. But we are saying that as the object is falling, there is the force acting downward. Remember, there was a question talking about the forces acting on the object. So this object's falling downward. There's a force pulling it downward, and this is the weight. The mass of the product of, remember, weight is equal to mass times gravity. So it's mass times gravity, telling us that this value downward depends on the mass. Now, as it falls, there is also an opposing force, which we call air resistance. Now, as the object falls, the velocity downward increases, as well as the air resistance increases. I'll give you this example. When you are running slowly, the air resistance, you might not even feel it. But when you're driving or when you maybe you're riding a bike at a very fast speed, you experience more of the air resistance. So meaning as the speed increases, the air resistance also increases, while the weight remains the same, because the mass that you're multiplying with the gravity, the mass does not change regardless of the position, and this G here is 10, so these values cannot change. But because the air resistance in an upward way is increasing, meaning we will reach a point where the downward force and the upward force become equal in sizes. And when that happens, we say that the object has reached terminal velocity. We say the object has reached terminal velocity. So terminal velocity is a type of velocity that objects experience when they are moving at a constant speed. How does it happen? This only happens when the forward force and the backward force become equal. Actually, the force that is causing this object to go down, it's the weight. So this is actually called the driving force. And this force which is causing the object to reduce its speed is opposing its motion is called the dragging force. So when the dragging force and the driving force become equal, the object reaches the terminal velocity and it starts moving at a constant speed. Now, when we say constant speed, we are saying that the speed is the same. Constant speed. Now, when speed is attained, there is no acceleration. Why isn't there any acceleration? Because acceleration is the rate of change of the velocity. So now because the velocity becomes constant, then the object moves at zero acceleration. Can we move on, or is there a point that I need to talk about?
And I think I'm okay here.
Okay, so we move on now to the next slide. The next slide now talks about the opposite when an object is thrown upward. So one of the things that we have here is that, please, we have to note, we are not going to say remember because we might have not learned it. So we're saying note, take note, that when an object is thrown vertically upward, you are applying force on the object, upward. And because that force is applied, the object will not start moving with initial velocity of zero. No. There it was zero because the object started undergoing free fall. At the beginning, there's no force applied on it from the external source. But here, we are throwing it. And therefore, the initial velocity is bigger than zero. Because the object is going against gravity. So if the velocity is zero, we don't expect it to move. And gravity is pushing it downward, and we want this object to go upward, there will be no movement detected. So saying how far this object goes depends on its mass, though mass is somehow a non-state function. We don't consider it much. That's why it's never indicated in any of the equations we're going to look at. But its initial speed will determine how far this object goes, as well as the amount of force applied on it. Now, the reason as to why the object that is falling from up the skies, it will eventually reach the ground because the velocity is always positive. It's always added. But now here we are saying that when you throw that object, it will not go forever up there. There will be a moment when to change the direction, meaning the value of velocity increases or reduces, rather. But it reduces by what value? It reduces by the opposite, which is 10 meters per second. So if you throw an object with initial velocity of 40 meters per second, we expect this object to only go upwards for 4 seconds. Because each second that passes, we are going to subtract from 40, you have 3. Number 2, you're going to subtract, you have 2. The third second, you're going to subtract, you have 3, or you have 1. The fourth second, you subtract, you have 0 velocity, then the object starts falling downward. So we're saying that the reason as to why there's a reduction in velocity, because the gravity is not actually pulling the object downward, but is acting on the object in the opposite direction. So because now the velocity is changing, is reducing, we are saying that that is actually negative acceleration, which is also called deceleration, or also called retardation. So in the moment when the velocity is increasing, you're approaching the roundabout, you're approaching the traffic light, or maybe there's an obstruction on the road, you step on the brake pedal, the speed reduces until, if it becomes zero, then the vehicle comes to rest. So simply that, which is a real explanation of what really happens on the ground. Can we move on?
Yes, sir.
Okay. Now, we are saying that how can we know the amount of initial velocity, the final velocity, how far it has gone, and all that?
Mhm.
This is one of the formulae that we use, where V here is a final velocity up there, but we know that final is zero. This U is the initial velocity that the object is started with. 2 is just a number. A is acceleration due to gravity, which is 10, and S is a distance. What does it mean? If we know how far this object thrown upward goes, let's say it goes by 40 meters. Thrown upward, it goes by 40 meters. What does it mean? We can substitute the value here, multiply by 10, multiply by 2, then this is 0. We take this value this side, and we can definitely compute the answer. We can find the initial velocity that this object was thrown with for it to have covered the distance of 40 meters. But in the moment where distance is not given, we only have the initial velocity, then we want to know how long it will take, we can use this formula. So basically, this formula that we have, which one to use, is determined by the parameters that are given in the question. Can I move on? Or maybe something
Yes,
I need to explain on?
not really, no, no.
Okay. So we are here now, where we're going to look at, now these are just a compilation of formulae, but we have a question at hand. So we have 6 minutes to crack the puzzle. So the question says we have to stop and think just for a moment. This ball is vertically projected upwards. It was thrown. We are given the initial velocity that it was thrown with. The question is, how far did it go? Find its maximum height. So this question is actually very simple because it's just it's just based on the formula that we're from talking about, where we have to say that S is equal to, so what do we have here? First of all, let's take down the data. What do we have here? Can you remind me of what we have here?
We have an initial velocity of 30
Initial
meters.
velocity, thank you. The initial velocity is 30 meters per second. What else do we have? What's the final velocity?
And our final velocity here is velocity. Is it 10 meters per second?
It's gonna be 0, buddy, because when the maximum height is at that point when the object starts now falling. So for it to change the direction, meaning the speed that it has finished. See the acceleration due to gravity. Now, because this object is going against gravity, the speed is reducing, the acceleration becomes negative.
Okay.
Yeah, so we can gladly plug this in the formula. Distance is equal to ut plus half a t and stuff like that. So we can definitely use this. Okay, squared. Where our initial speed here, but do we have the time?
The time given,
Time
no.
do not have. So we can go to the other formula, which involves the speed distance, which is v squared is equal to u squared plus 2 a what?
Two.
Did you take note of the formula?
Yes, I did.
2as.
Yes.
2as. So this is the one that we are using to compute the distance. So it depends on what we have. So for this one here, we have the final velocity, we have the initial velocity, we have the acceleration due to gravity, so we can actually find the speed.
Okay.
Where our final velocity here is 0 equal to the initial velocity is 30 plus 2, the acceleration negative 10 multiplied by s. So when we compute, we're going to have 0 is equal to 30 minus, because 2 times 10, 2 times 10, oh, v squared. This is squared. This is squared. Remember?
Yeah.
They use squared. So it's going to give us 900. 900.
Oh, yeah.
Then minus 2 times 10, negative 20s. Yes. So it's better we take this one, this side, which is negative, it becomes positive. So 20s is equal to 900. We divide by 20, we divide by 20, what answer are we getting?
Okay, so from there we're getting 4. We're getting 45.
45, yes. So the distance covered here was actually 45 meters.
Yes.
Then B says the time taken, how long did it take for the object to reach the starting point? Meaning we're considering how long it took going up and how long it took coming down. So we just find the one value, then we multiply by 2.
Okay.
So the best we would go for this one, because now we know the distance, we have the initial velocity, we can find time, we can also find time here. But because time here becomes squared, so we can use the other one, which is this. So this one is actually much easier. So I'm sure you can compute this equation and then find the answer. So we are using the free version of WhatsApp. We've been reminded that we have less than a minute, unless you have questions. Otherwise, I'm going to send you this question. You have this and the other questions to do. Please ask questions.
Okay.
Question.
Okay, so the first formula, is it only given to only find what can I say?
Any of those
If
that
we're only given like every type.
the only way you can use this formula